Hi guys, welcome to the channel. So today we'll learn one more problem from the array, that is the medium level problem, that is basically container with most of the water. So let's understand the problem. So you're given an integer array of heights of length n, and then what we need to find the two lines that together with the x-axis from a container such that the container contains the most of the water. So let's understand with this diagram. So here we have draw this array with the x and y axis, and then if you draw this array, if you notice, then in the second and the last line the water capacity is maximum. Let's say if you store the water from first to last, then it will be over here, it will be like starting from this and ending with this, so it will be 1 cross 8, I think, so that will be 8. But if you store the water between second and last pillar, then the water capacity is 49, so that is the maximum in this array. So that is the problem basically. So let me draw this problem in OneNote, and then we can see how we can solve this problem. Okay, so I put the array in a OneNote, and then I have pasted the same image which was given on the question. So let me quickly give the indexing. So this is the first, two, three, 4, 5, 6, 7, 8, and 9. Okay, this indexing is given. Now let's understand how we can solve the problem. So approach 1, let me write it as approach 1. So now in a basic approach, basically that will be our brute force algorithm. Let's try to understand how you can solve in a brute force approach. So let's say I'm starting my loop from this index, and then I'm keep on, like this will be the I, and then j will be here. So I'm keep on increasing the j, and then I'll try to store the water. So let's say in our first iteration, so I will be 1 and j will be 2. Now how much water we can store from this one? So it will be like this, right? This is basically the water which we can store, right? If we go beyond this one, so it will overflow. So how much we can store? It will be 1 cross 1, that will be 1. That value we will basically store in our max. Now we'll increment the j to 1. Basically j will be pointing over here. Now if you see how much still we can store, although j is will be 6, but I will be 1. So again we will be storing to this level only. Now this will be this one. Now so this was when I equals to 1 and j equals to 2. Now if I equals to 1 only and j equals to 3, then again what we can store, that will be 1 cross how much distance, 1 and 2, 1 cross 2, that will be 2. So if you notice one thing, if you keep on incrementing the j variable, but still the height you can achieve of I only. So it's like wasting of the iteration. So in this way approach, let's say you have completed the iteration 1. So in iteration 1, what value, what the most value water you can store, 1 into me 1 2 3 4 5 6 7 8, 1 into my 8 is equal to 8 liter. So 8 liter only you can store in a first iteration. Likewise you will do with the second iteration. Okay, now in this iteration what you can do, your I value will be here. Let me delete this one as well. Okay, so your I value will be here, and then j value will be here. Now in this one, let's say, so okay, iteration 2, let me write it over here. Oops. Okay, iteration 2, let me write it over here. So in iteration 2, your I value will be 2 and j value will be 3. So let's say how much you can store with this one, so it will depend on the j variables, right? So this thing this amount you can store, right? Now your max will be, what is the height of this one? This is 6, and what is the distance? 6 into 1, max will be 1. Now let's say you have incremented j with 1, so j will be coming over here. Now how much you can store? This will be up to here, right? Whichever the lower pillar, up to there you can store, right? So this will be 2 and 2, So 2 into 2 will be 4, but that is less than 6, so your maximum will be 6 only. So likewise you will keep on iterating it, and till the end you will be getting your answer. So the complexity will be, so the time complexity will be, oops, so the complexity will be order of n square, because what you are doing, you're keep on iterating one again and again, so there will be two loop I and j, so that will cost us to order of n square complexity. So is there any other way that we can solve the problem with the order of n approach? So let me show you. Okay, so let's discuss the approach number 2. In this approach, basically what we're gonna do, we will be using the two pointer approach. Two pointer approach. Now what is this two pointer approach? In this thing, we will be having the two pointer, let's say I and j, and then they will be moving in a one iteration only. Either they are chasing, either I is changing to j or j is changing to I. So let's understand. Here, let me point it I over here and then j over here. Okay. Now let me do this. Okay. So in iteration 1, basically we will be having only one loop, that will be one for loop. In iteration 1, now what we will see, we'll see, we'll try to calculate the water between I and j. So now I is 1 and the height of j is 7. So in this case, if you try to calculate the water, now what is the, what will the water is getting stored? So it will be, okay, so let me write down the formula for this one. So the formula will be, let me delete the iteration one. So let me write down the formula. So the formula will be height of lowest into may into difference between these pillars. Okay, so let's say in our iteration one, so what is the height of the lowest? So height of the lowest, I height is 1, j height is 7. So the height of lowest will be 1 into the difference between these two. The difference between these two will be 9 minus 1. So that will be 8. So the maximum water which we can store will be 8. Now, how do we know I will be incremented by 1 or j will be incremented by 1? So first is that this is the formula. Second is that whichever height is lower, that will move. Okay, so in our case ith height is lower, so I will move basically. So what we will do, we'll put I over here. Now let's see in iteration 2, our max will be, so our max will be height of the lowest. So in this case ith height is 8 and jth height is 7. So in our case this will be 7 into difference between these two. So difference between these two will be 9 minus 2. So the 9 minus 2, then if we evaluate this one, so 7 into 7, that will be 47. Sorry, 7 into 7 will be 49. So our max will be 49. Let's see in iteration 3, it will get the clarity. So in iteration 3, basically what we will do, whether I or j will move, so that whichever height is lowest, that will move. So in our case jth height is lower, right? So that will move basically. So here j will be over here. Now if you notice, first time we incremented one I by 1, second time we decremented j by 1. Now if we try to calculate the max, let's say if I calculate the max, then this is the height of the lowest. So if let's say jth height is 3 and the ith height is still 8, so our lowest height will be 3 into, what is the difference? So 8 minus 2. So 8 minus 2, now 3 into 6, that will be 18. But again 49 will be the max. So if you'll complete the iteration till the end, then notice that you will be getting the maximum water, that will be again 49. So that was basically the solution of the code. Now our question is why we took the height of the lowest. So let's understand. In our iteration 1, basically we were over there, right? Let me erase it. and let me erase this as well. So in our iteration 1 we were basically here, right? I equals to 0, j equals to, so why we incremented I? That is the problem, right? That, so why we incremented I? Now if you see in first iteration, whatever amount we stored, it was like this, right? It was like this, correct? Basically this amount, that was basically 8. Now why we incremented I is because if you decrement j also, then the amount of water that you are storing between these two is going to reduce, right? Because why? Because let's say in our case, let's say you are not incremented I, you are just decremented the j, right? Now j will be here. Now if you see the amount of the water that you can store, that will reside with these, right? And if you calculate this one, so that will be 7 into 1, that will be 7, so that is basically less than 8. So what we are doing, we are just omitting the extra checks that we don't need to do, because we already know if we do those checks, that obviously the water will be less only from the output that we already know. So yeah, I hope you cleared the question. So if you have any issue, just write down in a comment. Thanks.